I really appreciate this opportunity to come to Australia. This is my first time here. I was in Sydney last week. That was really nice. There was a nice conference there. Got some surfing in. Now I'm in Melbourne. The cafe scene, the restaurants, been amazing. Also the sightseeing. I've also really enjoyed the different phrases, like learning the different terminology, some of the words a little different. Good day, of course, that was sort of expected. But we also have different names for all these common things that really surprised me. For example, I went on this tour yesterday, and you would not believe it, but in the States we call these kangaroos. So anyway, it's just really, it's interesting to see these differences. But that's not the subject of this talk. I wouldn't come all the way over here to tell you about ultimate penguins. You know all about them. So this talk will be about delivering responsibly. Looks like the slides died for a moment there. All right. So let's get started. So as web designers and developers, our job is to build sites and services that respond appropriately to our users' needs. And while responding, the idea of responding or reacting sort of sounds like a passive act or reactive act even. If you've built sites that work really well across devices before, you know that's hardly the case, right? Our sites need to respond to all sorts of factors and conditions. And reacting to those factors and conditions intelligently demands a very proactive and tireless practice. Right? It requires careful consideration, forethought, research, testing, a little bit of creativity sometimes. Because ultimately, we want to deliver sites that feel at home on any particular device, feel really appropriate on that device. And the more we meet our users' expectations and their intuitions even, the better and more efficient our services and our reach becomes. So to do that, our sites need to respond appropriately in many ways. Some examples of that. Our user interfaces need to respond and adapt appropriately to a device's screen or viewport size, and to adequately prepare our sites for those screen size variations. We can use that magical combination of fluid layout, fluid media, like images and video, and CSS media queries, responsive design, right? Slide advance, please. I'll just wait for this to play out. So that's a responsive design. All right. So, of course, there's more to it than just screen size alone and viewport size. Along with screen size conditions and considerations, we need to pair the fidelity of our components that comprise our overall layouts with what can be expected of a particular device's capabilities and support, right? So this means qualifying the application of the features that we deliver so that they can be made safely, so that we don't try to make enhancements that can break an already usable experience. Additionally, our interfaces need to be usable and respond to a variety of input mechanisms. So keyboard, mouse, touch, assistive technology like screen readers. Most devices offer multiple means of interacting with a page, multiple input modes. So in preparing our sites for input, we need to be really careful not to make presumptions or assumptions about any one input mode being in play at any given time. Often there are many in play. So that means, from a CSS perspective, maybe larger click areas for tap targets. For JavaScript that ties into that CSS, maybe we need to use more traditional event handlers, like click events, and then layer on top of them, so that they support everything a little more broadly. So those are just a few ways that we need to make our sites respond appropriately, right? But before we can even consider those things, we need to respond in the first place, right? And we need to respond quickly. So we need to consider performance. We need to respond to requests for our sites over the network. So today I'm going to talk to you largely about delivery, that aspect of responding over the network. And CSS is largely involved, but there's all these other technologies on the client side that kind of tightly interweave with the CSS. So I'm going to show you some techniques that treat performance and delivery in a sort of progressive enhancement sort of mindset. So it's a progressive process of delivering a site. And I'll show you a little bit about how those techniques that we're using these days are going to evolve over time, because some of our standards are changing. So let's start by talking about some of the performance and delivery problems that we face already today. Of the many advantages that we have in building on the web, I think the greatest advantage is reach. Right? Being able to reach the broadest number of people. The web broadens the reach of our services unlike any other technology, right? Far better than any single native app platform can provide. And given the varied nature of how everyone accesses the web, our sites tend to reach folks who access the web under very different conditions than some of us have as designers and developers sitting at our desks at home. So despite the fact that we have this unique, distinct advantage when we choose to build with web technology, it's common to find sites that are built in exclusive ways still, right? And not always intentionally, often not intentionally, but it inhibits their reach, right? Often due to assumptions that we make when we're developing our sites and conveniences, decisions that we make that can end up affecting delivery, impacting it in ways that is not necessarily desirable for our users. And I think that's a missed opportunity, right? We're excluding people with less than ideal browsing situations than our own. That's bad, of course. That should make us feel bad. But there's, of course, a business argument, a business case for access as well, right? When we talk to our clients. Here's an example of that. There was a Wired magazine article last year that talked about some Facebook executives who were traveling through Nigeria, which happens to have a really large population of Facebook users. And they went to one of those kiosks to purchase a device that was sort of common to what people use to browse the web in that region. And they installed their app, and they pulled it up, and they made this observation. They just sort of, they were waiting and waiting. Just nothing was happening. The timeline wasn't showing up. And they said it seemed as though they had been building for users like themselves back in Silicon Valley with all the latest gadgets and fastest connection speeds in the world. But given their global audience, Facebook, it's everywhere, right? They were actually the exception, right? They were an edge case. So I think it's kind of an interesting observation. We web developers tend to be kind of an exceptional bunch in that way, right? Our work demands really fast, reliable networks so we can stream enormous amounts of data back and forth. And we have access to all these devices to test on, including the one that we do our development on, right? So those can start to fog and limit our vision to sort of a tunnel, right? So while many of us work in ideal conditions, or relatively ideal conditions at home, we can't just build for users like us, right? We can't forget that for much of the world, the web doesn't necessarily always work quite that well. So I think as web designers, we're in a really unique position to impact that situation for our users through better practices. And overall, in many ways, we could be doing a better job. So we need to build with empathy. When we talk about performance, you often see this chart come up in a lot of performance-oriented talks. This was last month's data. This is the average size of the most popular websites on the web, something like the top 300,000 or something like that, websites. Almost 2 megabytes, so pretty heavy, right? And perhaps obviously that's quite a problem. Like, it's a real problem. But it's not our only problem when we're thinking about performance. But it's a real problem because for many of us, data is finite, right? We often have shared data plans across many of the devices that we're using, and they have a cap on how much we can use per month. Many people browse the web with prepaid SIM cards, and once those are spent, you have to go down to the store, get a new one, recharge it up. So in these cases, access can be expensive and prohibitive, right? There's a real cost to accessing the web, and sites like as heavy as that one can start to really chip away at that quickly. Anyone seen this site? How much does my website cost, or what does my website cost.com? It's really great. Tim Cadillac put this together. I think it launched a couple of weeks ago. And I think it does a great job of really quantifying the cost of a website to people who browse the web in limited contexts with constraints. So for example, Disney.com weighs just a little over 4 megabytes. And if you scroll down this page, you can enter any URL, but I entered Disney.com. You can see how much it, on average, costs just to download that, just to visit that site once. Like in Vanuatu, it costs $1.30 USD. So pretty expensive just to visit a page, right? So access can be pretty prohibitive in that way. So the good news about this is that there are really easy ways to do a better job and reduce that cost when it comes to weight. To start, we can be compressing everything, right? So reducing the size of our actual assets that we're requesting over the network so that, they're lighter for travel. So making sure our images are compressed, making sure that we're using file formats that really take advantage of the latest technologies to crunch them down. WebP for images, things like WAF2 can get a font's file size down without necessarily changing the quality of the deliverable. On top of that, we can optimize our text files, remove white space from CSS, JavaScript, even HTML can be minified. And then, of course, any text file that we send over the network should be gzipped, right? Compressed for network transfer so that the browser can unpack it. It's really small to download. And in addition to optimizing our images and just making the files themselves smaller, it often makes sense to actually serve or offer up different sizes of a particular image to the browser and either dictate which version of the image should apply in certain cases or let the browser decide. Fortunately, our community has been doing a lot of really great work in the last couple of years to get some features into browsers that help us do this in a standards-based way. So responsive images is what I'm talking about in particular here. 2 features that are now landing in all of the new versions of the browsers kind of slowly, already in Chrome and Firefox, iOS, Opera. Source set, an attribute that we can apply to image elements, and the picture element, which sort of lets us offer up different sources based on media queries and pair those sources with breakpoints in our design. We can also make efforts to reduce our dependencies within our code, right? So frameworks that we pull in from the start can bring a lot of bloat sometimes. And things like Bootstrap or jQuery have really nice build processes, so we can try to take only the parts that we need and nothing that we don't. We can also sometimes post-process them to analyze which parts we're using and remove the parts that we're not. So that's nice. It's also nice if we can avoid frameworks entirely, because often we can get a much lighter experience. So there's always a trade-off there in maintenance and figuring out what makes sense for each project. So optimization helps, right? Helps get the file size down, but that's not our only concern with performance, and maybe it's not even our main concern. It turns out that optimizations like that only get us so far, right? And only recently have we begun to acknowledge that. So it turns out that the size of our sites, the raw size, isn't really our users' biggest problem. The problem is the speed of light. Ilya Grigorik from Google has a nice article where he talks about this, and actually has a great book where he talks about this too, and you should really read it, and really every article he puts out. And in this article he says, the web's performance problem isn't bandwidth, isn't file size, right? It's latency, right? It's the physical distance between the server and the client, the browser. Our code needs to travel distances over the network, and that takes time. So a trip to the server and back sometimes takes a lot of time. And we can break that down a little bit. The first latency issue tends to happen when we're just connecting to our local ISP or our carrier. On a landline or Wi-Fi, that can take up to 150 milliseconds just to ping the local ISP. On a cell network, it can take a lot longer. Try a second or so, right? Just to connect to the tower. And then depending on how recently your device has talked to that tower, it may take a little longer, maybe 1 or 2 seconds on top of that to establish a radio connection with the tower again. So big delay there, a lot of latency, and we haven't even gotten to the network, right? We're just talking to the local carrier. So the second part of the latency is one that we can really have an impact on. And that's related to physical distance. Right? Our code is hurtling around the world on these fiber networks, cables, right? And even at nearly the speed of light, that distance starts to add up, right? This is why CDNs matter, right? CDNs are still so important because we're trying to get as many servers as close to our users as possible throughout the world. So those round trips are shorter. So it's about proximity. So it turns out that relationship of distance and traveling over the wire can be made fairly tangible. I like this video by Grace Hopper, who was one of the first computer programmers. She used a physical length of cable to describe this relationship of latency. So I'm going to play this for you.
Hopper.
They started talking about circuits that acted in nanoseconds, billionths of a second. Oh, I didn't know what a billion was. I don't think most of those men downtown know what a billion is either. And if you don't know what a billion is, how on earth do you know what a billionth is? I fussed and fumed. Finally, one morning, in total desperation, I called over to the engineering building, and I said, please cut off a nanosecond and send it over to me. And I've brought you some today. Now, what I wanted when I asked for a nanosecond was, I wanted a piece of wire which would represent the maximum distance that electricity could travel in a billionth of a second. Now, of course, it wouldn't really be through wire. It'd be out in space, velocity of light. So if you start with the velocity of light and use your friendly computer, you'll discover that a nanosecond is 11.8 inches long. The maximum limiting distance that electricity can travel in a billionth of a second. Finally, at the end of about a week, I called back and said, I need something to compare this to. Could I please have a microsecond? I've only got 1 microsecond, so I can't give you each one. Here's a microsecond. 984 feet. I sometimes think we ought to hang one over every programmer's desk or around their neck so they know what they're throwing away when they throw away microseconds. Now, I hope you'll all get your nanoseconds. They're absolutely marvelous for explaining to wives and husbands and children and admirals and generals and people like that. An admiral wanted to know why it took so damn long to send a message via satellite. And I had to point out that between here and the satellite, there were a very large number of nanoseconds. You can explain these things. It's really very helpful, so be sure to get your nanoseconds.
I love Grace. Okay. So she's talking about communicating with satellites, but it's kind of the same, it's the same problem. Our code's traveling distances, and that time adds up. So nanoseconds, as Grace was talking about, or milliseconds, as we often talk about on the web, can seem insignificant, but they really add up to noticeable lag quickly. Tammy Everett, who blogs a lot about performance, published a study recently that gathered user feedback on several e-commerce sites that were user tested, both at their normal speed and also with a simulated latency of 500 milliseconds on any request. And on the left, you can see the terms that were used to describe those same sites before that latency was applied, and on the right, how people describe those sites, just with 500 milliseconds delay. So it really starts to add up. It's pretty amazing. So trips to the server and back take time, and we want to make the most of them, right? And one way to sort of make the most of them is kind of like carrying groceries, I find. So anyone else done this before? like trying to make the most out of that trip back from the car, this is how you build a fast website. Thanks for coming. So you want to get the most important stuff on that first trip back from the car, right? Often we can't get all the groceries in that first trip back, so we sort of have to prioritize, maybe get the cold stuff first, go into the freezer. I'll stop with that metaphor now. But you get the idea. Given that latency is a factor, we want to see what we can do to work alongside it, because it's there, right? So we want to see if we can improve the perception of the performance of our sites. What can we do about making it seem as though our sites are loading and usable a lot sooner? So there's this concept of perceived performance, and it's measurable. It's different than we've traditionally talked about performance, though, in terms of overall page loading time. If you read up on perceived performance and loading time and rendering time, you're going to run into this term called the critical path. It represents the steps that occur between the time that you make a request for a site and something is rendered onto your screen, right? And if you think of that path sort of literally, like a walking path that you're walking down, you can imagine that there are obstacles along the way, or there might be, or detours even, right? Like this fence in the woods. In the context of web pages and delivering them, we don't want obstacles at all on that critical path. Probably don't want them walking through the woods either. But we want the shortest, fastest path to rendering our pages. And oddly enough, some of the standard ways that we've been building sites for ages now act sort of like obstacles on that critical path to rendering our page. One is the way in which we reference our assets, at least in a standard way. And there are ways we can work around this, but just by default, references like this to style sheets and JavaScript files act like obstacles, right? And that's because the browser will actually wait for those to be request to the server and return back those round trips before it'll show the page, render it to the user. This is known as render blocking, right? And it's sort of a good and a bad thing. It's good in the context of CSS that we need to render the page, because we don't want to render the page before we have the styles to render that view. Otherwise, you get a sort of unstyled version, and then it blinks into place with the full layout when the style sheet arrives. So we like some blocking to occur. But it's also bad when we are introducing latency, those round trips, in a blocking way. We're waiting for additional requests after the HTML has already been downloaded to the device before we can render it. So we want to do something about that. And this is where optimizing assets alone can't really help us, right? It's still going to be another round trip if we have to go get it from the server, even if it's lighter, and latency starts to become a problem. So we want to avoid requesting them externally at all if we can, get our pages to render sooner. Fortunately, in the last year or two, some really great tools have come out that have helped us analyze the critical path to rendering and figure out where those roadblocks and bottlenecks are occurring so we can work around them. Webpage Test Org is one that I'll highly recommend if you're not using it already. It's part of our daily workflow now. It's such a great tool. You enter a URL, you choose from a number of servers throughout the world, browsers, different devices, and you hit start, and it'll load that site in whatever browser device combination you choose and give you all sorts of great information about how it loaded. Here's the summary page that you get after requesting our site, Filament Group, where I work. And you can see at the top of the page, you get a nice little table at the top. It's kind of like the high-level numbers that you want to care about first. Things like how long it took to load the entire page, all of its assets. How long it took for the time to first byte back from the server, so round-trip latency time. And then there's some more interesting stuff, I think, for perceived performance, like start render. And what that tells you is the time that it took for something to start visually displaying to the user. So here I'm showing Filament site again, and you can see it's around, 300 milliseconds, something like that, which is really, really fast, right? It's been highly optimized based on using this tool to figure out what we can do to improve that start render time. So the numbers say a lot, but I think what's more interesting is this timeline view, because it starts to visualize our page loading process in keyframes. And you can see how it has 100 millisecond increments here. And by 600 milliseconds, everything is finished loading. But of course, like I said, this kind of speed rarely happens by mistake, right? You have to really optimize the way things progressively load to get something rendering that soon on the timeline. So let's look at some of the ways that we were able to do that. So it turns out that a little awareness in the way our pages are transmitted over the network can really go a long way. When we request a page, usually we're making many round trips to render it. But that first round trip is sort of interesting, because on average it tends to carry back from the server around 14 kilobytes of HTML. Hypothetically, if we were able to pack everything into that 14K, then we'd almost be guaranteed that our site would render in under a second. If it included all the JavaScript, CSS, everything that it needed, right? But of course, most sites weigh a lot more than 14 kilobytes. So this is when we start to think about how to prioritize. Coming back from the car, which groceries am I going to carry? In this case, what are the most important parts that I want to bring back in that first round trip? So in thinking about that, Google has this tool called PageSpeed Insights. And one of the tips that it offers, amongst many, it's a really great tool, it says, it actually deals with this first round trip. It says, identify and inline the CSS necessary for rendering above the fold content. So the idea is that for above the fold portion of the page, we want to avoid making requests for anything that's necessary to render it, especially the CSS. Now, I know what you might be thinking when you read that. There's that term, the fold, right? And we thought we were done hearing this, and now it's come back in the last year or two. There is no fold on the web, right? We know that. Across many devices, there are many folds. Here are just a few. So it's an old term borrowed from the newspaper industry to represent the height of the visible viewport, and it changes from device to device. But I think in the context of this advice, we don't need to get all up in arms about it. It doesn't need to be controversial. All they're really saying is pages load in a standard way, top first. You see the top portion of the page before you see the rest of the page further down. So if we can optimize the way we deliver the page so that it renders progressively as well from top to bottom, that's sort of nice if we can show something a lot sooner, right? So how do we know which CSS is for the top of the page? Well, some folks from Google wrote a nice article about this. They wrote a bookmarklet that identifies the CSS that's necessary for rendering just that top portion of the page. And it looks like this. When you run it from a code perspective, you can imagine a full style sheet on the left. Obviously, it would be more complicated than this. But then on the right, we have the critical styles, just the ones that apply to elements that happen to reside in the top portion of the page. So it's a subset. Visually, it's kind of more interesting. This is a page from Filament's site, an article. And on the left, we have the fully styled version with its full style sheet. On the right, we have that same page with just its critical styles applied. And you can see that we analyzed using that red line across the middle as kind of our bar for which portion of the page was deemed critical. So anything above that's critical. And what's kind of cool is you can see that the design just sort of falls away in the right. The styles for that portion of the page aren't there yet. So we know that the tool's working. This is what the bookmarklet does. So that's sort of cool. Bookmarklets are kind of a manual tool to use, though, right? So for maintaining critical CSS on a big code base, you might want something more automated. At Filament, we use a tool called Grunt Critical CSS. We actually maintain it ourselves. There are a couple other tools out there for various Node.js, mostly, environments. And the way this works is we run this command line task anytime we finish saving a CSS file. And it'll open up unique templates on our site, all of them, and run that same sort of process that the Google tool did, the Bookmarklet. Analyze which portion of our CSS is necessary for rendering the top, and write it to a file for each template. So if you look at the task, it's probably kind of small for folks in the back of the room, but this is sort of how it looks in code. We have a list of the unique templates, maybe our homepage, article template, things like that. And then for each one, we have a little configuration. We have a URL that the browser can open to view an example of that unique template. We have a reference to our full style sheet that it wants to analyze. And then we have a file name that it can write the critical portion of those styles to. So one file per unique template. So once we have those files, that's where things sort of get interesting, right? Because now we can start to take Google's advice from the PageSpeed insights and do something with that critical code that we extracted. So this is when we're going to start inlining it. And this is when we can start to think about cramming the important portion of our code into that first round trip back to the server. So first, let's look at how that looks in CSS. This should be new to no one here, I'm sure, but in CSS, we can inline code using a style element, and that's sort of how it looks to include some CSS directly into an HTML document. Since we're writing the critical styles to a file, often we see it more like this, or a build process or an include, something where it's dynamically including the CSS rules for that template. So again, that's only the critical styles for that template being inlined, right? Not all of them. And of course, we're going to need to load the full style sheet as well, but before I get to that, let's jump over to JavaScript and see the inline critical portion of the JavaScript and how we do that part. So in JavaScript, we have the script element. It's the same thing for referencing something external or pulling it into the page inline. And it looks like this. Again, I've used the include sort of pseudo syntax here just to demonstrate, and I'm including a file called initial.js. So that's the stuff that we've deemed critical enough to include in the head of our page. So that brings the question, what is critical JavaScript, right? No JavaScript should be critical, ideally. But when you're building with progressive enhancement, often it's really handy to have a little script to help you out when you're progressively enhancing the page. So some of the things that go into that initial JS file may be some feature tests, sort of like Modernizer has, something to load additional assets, like additional style sheets, JavaScript files, some logic to decide whether or not to load those files at all. So that's something we can't really do natively in HTML, right? We can't reference a script tag under particular conditions, like only if this feature is supported, without some sort of logic like that. So a script loader can be really handy in that situation. And then some stuff for loading fonts that I'll get to in a second. So for loading CSS, just to explode that out into code, you can see there's a function up here. You don't really need to look at the innards, but you can see that it loads a style sheet. And it does so in a way that doesn't block rendering. So we can call it at the bottom, load CSS, and that's a path to our full style sheet. It's going to load in asynchronously and just appear whenever it's ready. Render the bottom portion of the page. And then we do the same thing with a script loader, right? Load script or load JS and pass in a path to our full JavaScript that might include our DOM framework, UI kit, stuff like that. And then to show you some of the conditional logic that might go into whether or not we call load script, this is what we typically do, or at least a simplified version of what we often do. Cutting the mustard, anyone heard of this? This is a technique that the BBC named recently, but it's just a broad qualification. So in this case, we're checking if a couple features are supported before deciding to load our DOM framework that makes use of those features. So to bring that all together, this is kind of the head of our page once it's all set up, right? So we've got inline styles, we've got a script block that loads the full style sheet without any conditions, and then maybe loads the JavaScript enhancements if it's a modern browser. And then below that, I like to link up to the full style sheet with a no script element, just so it works in non-JavaScript contexts. Additionally, once we've loaded that full style sheet, we can consider it to be in browser cache. So what we like to do at Filament is set a cookie alongside that call to load that style sheet, and then we can configure our server-side templates to say, if that cookie's there, no need to inline all those styles for each template. Let's just reference that style sheet directly. So that's the inlining portion. Fonts are a big problem on the web. They're a big problem to perceive performance because the way that browsers tend to load fonts by default, or some browsers these days anyway, is kind of awful, right? They hide the text of the page that's going to be styled with a custom font until that font finishes loading. We call it a flash of invisible type. So if you browse iOS Safari, you probably see this a lot. Here's a page where the HTML has already downloaded, and we're just waiting for a custom font before the text will show. It's really annoying. In iOS, this can take as long as 30 seconds because that's just the default timeout that browser uses. So recently we've been trying to find a good way to work around this approach, kind of a happy medium, and I wrote an article about using font events, or at least simulated font events, to try to show default text, fallback text first, and then show the custom font when it's ready to come in. It sort of works like this. It's a modernizer kind of approach from a CSS perspective. We've got a default style applied to our heading, in this case, an H2, just a sans serif font. And then once a fonts loaded class is available on the HTML tag or something like that, we can apply the custom font that was loaded. And we use a little JavaScript, in this case, Bramstein's font face observer, to apply that class. Listen for whether the font has loaded yet. Once it has, apply a class. And what's nice about that is you can see that although the last couple of keyframes are the ones that have the custom font here, we've still got text showing all the way through. So if we didn't apply this little workaround, it would be blank text until the last frame when the custom font was ready. And that can be a really long delay. So to wrap up that stage of the optimizations for initial perceived performance, I wanted to show a quick case study. Wired.com recently redesigned Responsibly, and they made this really beautiful new site. This is an example of their article template. And it's really nice, but if you're browsing it on a mobile device, particularly over a 3G-ish connection, you'll notice that it leaves a little bit to be desired from a performance context. And actually, this is not poking fun at Wired in particular. This is actually pretty average for a site of that scale. So I just chose this one because it didn't happen to have these optimizations applied. But you can see it renders usable content on 3G, on Chrome, on Android, around 12.5 seconds. So for example's sake, I pulled that site down onto our private servers and started applying some of these optimizations that I just showed you. So extracting the critical CSS and inlining it, loading the full style sheet asynchronously without blocking, loading all their scripts without blocking, so that includes ads, which can be really problematic, and then that font approach that I just showed you, so allowing a default font until the custom font's ready. And you can see that the impact is pretty dramatic. 3G Chrome, again, on Android, we get usable content text starts to appear around 4 seconds instead of 12.5. So we just cut quite a lot off of it. Now, I should point out that the end result is identical, right? It's just we're favoring a more progressive page loading process instead of an all or nothing one, right? So you can see on timelines how they compare. And it's important to point out that that's actually a pretty heavy site, too. So we always think of performance as a file size thing, right? And we're starting to get away from that now. at least from perceived performance perspectives. This is a 9 megabyte page when it finishes loading, and we're still rendering it very quickly on 3G. Okay, so to wrap up, those are some of the steps that we can do to improve perceived performance today, right? But how are they going to look in the long term? Well, they're workarounds, right? We've been applying workarounds for performance sake for a long time now. Concatenating files, inlining, all these things that I just showed you. And ideally, we don't want to do those things. So luckily, in the future, there's a new version of HTTP that has already started working its way into browsers, version 2, that's going to make a lot of this unnecessary. So essentially, a lot of the techniques like inlining that we're doing now to get a really fast perceived performance experience are going to be no longer necessary once 2 comes out. One of the reasons for that is this feature called server push, which is basically you can request a particular page, a URL for an HTML file, and the server can send back many assets that are related to that page that it knows you'll need, CSS, for example. So you don't need to inline it anymore. And those are just one of the few things that it'll really kind of make no longer necessary once 2 is out. So no more spriting, things like that. And it's going to take a little time. HTTP 2 isn't going to be supported in older versions of IE, for example. So we're going to need to keep both implementations going at the same time. So it's not going to happen overnight. You can consider it sort of another layer of progressive enhancement in that way. So to respond responsibly requires a lot of preparation and foresight, right? And I think I went over some of the ways that we can, at least today, start to make the perceived performance of our sites quite a lot more favorable for our users. And I think some of these methods are sort of harder for us, but they make it more convenient for our users. So I hope that I've given you a few things to think about today. My name's Scott. That's my book. I have 2 copies up here if anyone wants one. And yeah, that's it. Thanks so much for listening.